NumPy arrays are grid-like structures that can store data of the same type. They are similar to Python lists, but offer faster computation and more efficient storage. Indexing and slicing are crucial for accessing and manipulating data within these arrays. Before we begin, as always, we need to import NumPy as np, and we run that to import it. Now, one-dimensional arrays are the simplest form of a NumPy array, similar to vectors. Indexing and slicing in 1D arrays work much like in standard Python lists. To access individual elements in a 1D array, you use square brackets with the index of the element. Remember that indexing starts at 0. So we'll create our array 1D, which is going to be our example array, and we'll use the np.array function. And here we will provide a simple list of 5 numbers, so 10, 20, 30, 40, and 50. And if we want to take a look at our 1D array, that is our array. Now, if we want to access the first element of the array, we do it very similarly like we do with Python lists. So we do array 1D, and we use square bracket notation, and we use the number 0 to get the first element, and that of course returns 10, which is the first element. If we want the second element, we choose the index 1, and that returns the second element from the list. And if we want to get the last number from the array, then we just add minus in front of the 1, and when we run that, we get 50, which is the last number. Slicing allows you to access a range of elements in an array. Again, very similar to Python lists, the syntax for slicing is bracket notation followed by the start of the value, then the stop of the value, which is exclusive, not included in the range, and then finally the step. So if we want to get the second and third elements from this array, we would do array 1D. Then we start from the second element, which is indexed with the number 1. So we start with 0, and the second element is 1. So we start from the first index, and then we stop at the third index. So it'll be 0, 1, 2, and then 3. 3 is the value of 40, but since it's exclusive, we will only do 20 and 30. So we stop at 40, but we do not count 40 as one of the values that we want to show. So we'll do 3 because it's index 0, 1, 2, and then this is index 3. And then when we run this, we get an array with only the 2 values, so from the second and third values from the array. If we want to get all the numbers starting from the very beginning and up until the stopping index, then we just remove this one and leave this empty before the colons, and that basically represents all the numbers before the stop value. And then when we run this, we get, of course, the additional 10 value, which was the first index, so 10, 20, and 30. Similarly, we could go the other direction, which is we could start at some specific index. So let's say we want to start at the second index, 2, so that's going to be 0, 1, 2, starting at 30, and all the way up until the very end. So we then remove this 3 after the semicolon, so that just basically represents that we want to go all the way completely until the end of the array. And when we run this, we get starting from the 30, which was indexed with 2, and then all the way until the end. If we want to get every other element in an array, then we delete the 2, then we add one more colon, and then add the value 2. So this position is the start value, this is the stop value, and the third position is the step. So basically we're saying that we want all the values from the beginning all the way to all the values until the end, and then we want every other value. So the step is 2, every 2. And then when we run this, we get every other value. So it's 10, 30, and 50, skipping every other one. Two-dimensional arrays are like matrices. Indexing and slicing in 2D arrays involves specifying row and column indices. So let's first create our 2D array, starting by calling it our array 2D. And then we'll use the np.array function to create our array. Then we have a list. And then we'll provide, let's say, 3 rows. So first list is going to be 1, 2, 3. Then 4, 5, 6. And then 7, 8, 9. And when we take a look at our 2D array, we have our two-dimensional array, which is 3 by 3. Now, if we want to access different elements within our two-dimensional array, it's very similar as providing the row and column that we want to access. So each list here is considered as one row, and each element within that list is considered a column. So if we want to get, for example, this 6, then this is going to be row 1, because again, it's indexing starting from 0. So this is row 0, then row 1, then row 2. So if we want to get the 6th element, we want to select row 1, so index 1, which is this second element, which is a list. And then we want to get the third element, which would be technically the third column here. And that will be, again, the index of 2, because this is index 0, then this is index 1, and then this is index 2. So to get that, we will do array 2D. So like I said, we want the second row, so that's going to be index 1. Then we want the third element, which is going to be the third column, but it's indexed with the number 2. So we provide 2. And then when we run that, we get the value 6. Alternatively, you can use comma separated indices. So instead of using 2 bracket notations, we could just provide a comma, which is again the row and column. And when we run that, again, we get the value of 6. You can also slice subsets of the 2D array by specifying the ranges of rows and columns. So if we want to get the first 2 rows, then we would provide colon and then 2. So that basically means that we want to get all the rows and then stopping at the row with the index of 2. So again, it's exclusive, meaning that we want to get the rows 1 and 2, but we stop at the third row, which is indexed with the number 2. And if we want all the columns, then we add a colon here, which basically represents that for the columns, we want all the values starting from the beginning all the way till the end. So all 3 columns. And then when we run that, we indeed get the first 2 rows of our 2D matrix. If we want to select the first 2 columns and we want all the rows, then very similarly, we flip this around basically. So again, colons, which represents that we want all the rows starting from the beginning all the way until the end. And then for the columns, for each row, we only want the first 2 columns. So meaning that we want the columns starting with the index 0 and 1, and then we stop at the index column of 2, so which is exclusive, which is we do not include the third column in our output. And when we run this, we get our first 2 columns. If we want to get a specific subarray, then we could change this a little bit. Say, for example, that we want to get rows 0 and 1, so the first 2 rows, and we want to get the columns 1 and 2, meaning we want to get the second and third columns. So to do that, we will do 0 here, starting with the 0 row, which is the first row. And then we stop at the second index, meaning we are excluding the last row. If we wanted to include the last row, we would change this to 3, but we want only the first 2 rows, so we will change that to 2. Now we want to get the second and third columns. So here we start with the index of 1, which basically means that we are starting with the second column, and we want to include the third column as well. So we'll change this to 3, meaning that it stops at technically the fourth column, but we don't have a fourth column here. But if we want to include the second column, meaning we want to include this last column here, then we set this to 3 because the last column is indexed with the number 2 and we want to include that. But 3 represents the stop index, which is one number higher. And then when we run this, we get this subarray from our larger array that we had, which is the first 2 rows and the last 2 columns. Numpy arrays can have more than 2 dimensions. The indexing and slicing principles extend naturally to higher dimensions. So let's create a 3D dimensional array. We're going to call it array 3D, and we use our array function. Now here, we're going to provide 2 lists. In the first list, we'll have 2 more lists. The first one is going to have 3 values, and the second one 3 values as well. Then in the other list, we will also provide 3 values and another set of 3 values. And so this becomes our 3-dimensional array. And when we run this, this is how it looks like. Now it's a little bit hard to look at this and see how this could be a 3D, but basically let's comment this a little bit. Consider this depth 0, for example, and this will be depth 1. This is row 0, and this is row 1, and this again is row 0, and this is row 1. So think of it as a 3D cube where we have the first side of the cube, which has 6 elements and so it has 2 rows and 3 columns. And this is the front side of the cube. Then we have the back side of the cube, which has again 2 rows and 3 columns. So this would make up our 3D array. And so let's say we want to get the element value of 9. So basically, just like we've been doing in the 2D arrays where we provide the row and the column, we add one more dimension here, which is depth. So we first provide the depth, whether it's going to be the front side or the back side. So it will be depth 1 or depth 0. Then we provide the row and the column. So imagining our 3D cube, which is 2 by 2 by 3, we want to first select the back side of the cube, which is going to be depth 1, because that's on the value 9 is on the other side of the matrix. So we would do array 3D, and we choose the depth. So depth is 1, so we choose from this list. Then we want to select which row. So this is going to be the first row, which is going to be indexed with the number 0. And then we choose the column. So that's going to be the third column indexed with the number 2. And when we run this, we get the value of 9. And again, alternatively, we could combine this all together. and use comma notation, which represents depth, row, and column. And running that again gives us the same value, which is 9. Slicing in higher dimensions follows the same pattern. So let's say that we want to get the first layer of our 3D array, which means that we want to get all these values, which is the first layer, and we do not want to get the last layer of values. So to do that, we would change this slightly, and our notation is going to be 0 because we want the first depth or the first layer of the cube. Then we want all the rows, so we'll just add a column, and all the columns, which is going to be another colon. And when we run this, we get the first slice of the layer, which is these 2 rows. Now let's say we want to get both the layers, the front and the back layer, so the front and the back, and we want to get the first row only, and we want all the columns up until the second column, so that will be the first and second column, and excluding the third column. And when we run this, we get exactly that. So from the first layer and the second layer, we get the second row, which is indexed with the number 1. So it's going to be this row as well as this row. And from each of these rows, we want the first 2 columns and excluding the third one. So we get 10 and 11 and 4 and 5. Conditional selection allows you to select elements based on conditions rather than explicit indices. This is powerful for data analysis and pre-processing. You can use comparison operators to create Boolean arrays, which can then be used to index the array. So let's create a new array, call it R, short for array, and we're going to do np.array, and we'll create a simple 1D or one-dimensional array with 9 values. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now let's say we want to get all the elements less than the value of 5. So to do that, we would do R, which is our array, followed by squared bracket notation, and here we will provide the Boolean comparison operators. So here we want the array and all the values that are less than 5. And when we run this, we get exactly that. So all the numbers that are indeed less than 5. And if we change this a little bit, let's say we want all values greater than and equal to the number 7. When we run this, we get only all the values that are equal to or greater than 7. You can combine multiple conditions using logical operators as well, such as the ampersand for and the pipe for or. So let's start off with something simple, and let's say we want to get all the even numbers. So what we would do is we would use the percent sign for modulo, and we want to divide it by 2. And if the division by 2 is equal to 0, meaning there are no remainders, meaning that they're divisible by 2, which basically means that they're even, then when we run this, we get all the even values. Now let's say we want to get all the odd numbers that are also greater than 5. So we could slightly change this and say that we do not want the numbers to be divisible by 2, which will basically mean that they're not even. And when we run this, we indeed get the odd numbers. Now we want to add an additional condition that these numbers have to be greater than 5. And to do that, we'll put these in parentheses, and we'll use the ampersand as an and to say that we want this condition to be true, and we want another condition. So we'll put another set of parentheses and our Boolean logic. So we want the array values to be greater than 5. So we want the numbers which are divisible by 2 to not equal 0. So in other words, that we want only the odd numbers. And we want the values from the array to be greater than 5. And when we run this, we indeed get only 7 and 9. Now let's say we want to get numbers that are less than 3 or greater than 7. So we could change this slightly so to say that the array values are less than 3, or using the pipe sign to represent or, the array values are greater than 7. And when we run this, that is exactly what we get. You can also create a Boolean array and use it to index your array. So instead of providing these values directly into the brackets, we could actually create a Boolean array. So let's say bool array. And here we could provide the Boolean logic. So let's say array, which is arr, greater than 5. We want the values to be greater than 5. And then we can copy this logic and paste it into the brackets here. And then when we run this, it utilizes this logic inside these square brackets and it filters out exactly that logic. Numpy offers advanced indexing methods for more complex data selection. You can use lists or arrays of integers to select multiple elements. Let's say, for example, we want to select the elements at indices 1, 3, and 4. So that would mean index starting from 0 here. So it will be 1, skip 2, then 3 and 4. So it will be 2, 4, and 5. And to do that, we would create our indices. And this will be the array of indexes that we want to use. So it will be 1, 3, and 4. Then we would copy this and put this in our bracket notation here. And then when we run this, we get exactly those elements. Fancy indexing allows you to pass arrays of indices to select specific elements. So let's go back to our 2D array example. As a reminder, this is our 2D array that we used earlier. And let's say we want to get the values on the diagonal. So we want to get the values 1, 5, and 9. And to do that, we would create our row indices. And this would be a list. So let's say Numpy array. And our list would be 0, 1, and 2. Because we want to get the first, second, and third rows. And similarly, we could just copy this and paste it. And instead of row, it will be col indices. And again, we want to get columns 0, 1, and 2. So it will be column 0, and column 1, and then column 2. Now to get our diagonal values, we would do array 2D. Then we would pass in the row indices and then the col indices. And when we run that, we get the diagonal values. Become a member at AILearningHub.io and get access to personalized mentor guidance, early access to AI resources, help with AI projects, and a great learning community.